Okay, so I'm going to be explaining level 1 and 2 in this video. So level 1, the least common multiple of A and B is 12. The least common multiple of B and C is 15. And we want to find the least common multiple of A and C. So for LCM, for the least common multiple of A and B, we have that that's 12. And LCM of B and C, we have that that's 15. The common part in both of these is B. And we have that both of these are multiples of 3. So we have that B is a multiple of 3. And so we can just set B as 3 because, actually, sorry, we have to set B as a multiple of 3 because that's like the only thing in common for these two. And these two have to have a thing in common because of the B. So we have LCM of A and 3 is 12. If we have A equals 2, then the LCM would just be 6. So we have to have that A equals 4. And similarly, LCM for 3 and C is 15. We have to have C equals 5 because both are primes. So we have C equals 5. And the LCM of A and C is 4 times 5, which is 20. Yeah, and that's the least possible. Well, another, yeah, that's the least possible. So, for level 2, we have Chubby makes non-standard checkerboards, which have 31 squares on each side. And the checkerboards have a black square on each end. I didn't draw the whole thing because 31 is too large. And so we have a black square in every corner and alternating red and black squares in every row and every column. That means if this is black, then this would be red, and then this will be black, so it's alternating. And the same thing happens here. So we have that the start and the end is black, so we have 16 blacks and 15 reds. One way to know this is say that you have 30 squares, and that would just be 15 red and 15 black. Well, that's ignoring the like black square in both corners. So we say that like the left corner is black, which means that in this case the right corner would be red. And then so 31 squares, which means we add 1 square to the 30 squares, which is alternating, so it's adding a black, and that makes it 16 blacks. So we have 16 blacks and 15 reds on both sides. So to find the number of blacks here, we take, so if we look at it diagonally, like if we look at it like this, well, if you take it like this way, I guess. So you flip it over, and then so you make this side the flat side, and so you get this side. We get 1. We get that for the number of blacks, we have 1, and then 3, 3, and then so on. And that's just 15 squared. And the same thing happens for the red. So we have 16 squared, and so 15 squared plus 16 squared is 225 plus 256, which is 481.